So, step number 1, find the domain. What do I got to do? To find the domain. Set the bottom equal to 0. Then what? Okay, can I add 9 to both sides? Okay, what do I get? I like plus or minus 3 the best. Okay? Because when you square root, you have to take, and you're solving, you have to take plus or minus. I'm pretty sure that we said that at least 15 times just in this class. Fairly certain. So, what's my domain then? All real numbers. X cannot equal plus or minus 3. Now, here is where I'm guessing that 98.4% of you got it wrong. And what are the vertical asymptotes? No. Say it nice and slow.
X equals 3,
X
X equals negative 3.
equals 3 and X equals negative 3. Why do I have to split them up?
Well, I just had a quick question. How did you get like a plus or minus 3 versus just like it being...
Because you took the square root. Anytime you take the square root in your solving, you have to add in the plus or minus.
Okay.
17.
I really don't remember actually.
Why do they have to be written separately?
It's because the vertical asymptote, that's like the point on, there's like no point on the graph that's plus or minus 3.
What are they?
They're X.
Say it louder. They're vertical lines.
That's like what it is.
Yeah. They're vertical lines. Even though it was nowhere near what you were saying, but it's what you were getting there. You were going to Mozambique by going through Marathon. I get it.
Yeah, you know what?
I get it. Okay. They're lines. Okay, that's one reason. They're each distinct, not the same lines. Right? What's the real reason? You may know what the real reason why you write them separately is? Yeah. You guys don't do everything Lynn says. I already know this. I can tell from yesterday. Yeah, and from your plus or minus today. The real reason? Okay. It reminds you, oh, I got to put 2 vertical dashed lines in my graph. Okay, that's the real reason. Okay. Right. So from now on, Freddie, separated. No, it's not. No, it's not. You can still think it is too, but you know. Go for it. Snuffle. What do I got to put here? Atta girl. Domain. All real numbers. X cannot equal plus or minus 5. Vertical asymptotes. Okay. So we found the domain. We found vertical asymptotes. Now we got to think. Okay. So my end behavior. is going to be as x goes to infinity, what does, oops, my function is g of x. Does what? So if I get to a really big number, like let's say 1,000, what's my numerator going to be? 1,000. What's my denominator going to be? A really big number, right? Okay, but is it going to be positive or is it going to be negative? It's going to be positive. So I got a positive number divided by an even bigger positive number. What's it going to go to? 0 from above.
Okay, so wait, can I just clarify this real quick? This is what I have problems with this. Okay, so as long as the total outcome of the denominator is positive, that's
And the numerator is positive, it's going to go to 0 from above.
Okay, because I was confused because I was like, okay, well, if you have a positive for x, but it doesn't go to the negative, it doesn't go exceed like negative 25, like, you know, it doesn't cancel the negative out.
But we're talking big number. We're talking infinity numbers. You know what I mean? Okay. All right. So then as x goes to negative infinity, g of x is going to go to, are we sure? Okay, so now let's think negative 1,000, right? What's my numerator? Negative 1,000. What's my denominator? My denominator is positive, right? So a negative number divided by an even bigger positive number is going to go to 0 from below. Now, the last class said, well, because the first one was from 0 from above, the second one had to be 0 from below. That's a lot. Okay? You still have to do the logic to prove it, because we will have some today that they're both from above, or both from below. Okay? You still have to do the logic. Okay? Now, asymptote behavior. How many asymptote behaviors do I have? How many asymptotal behaviors am I going to have? 4. There's 2 asymptotes, right? So I've got left side and right side of each of them. That makes 4 total. So they are, as x approaches negative 5 from the left, what does g of x do? As x approaches negative 5 from the right, what does g of x do? As x approaches 5 from the left, what does g of x do? And as x approaches 5 from the right, what does g of x do? Okay. So, let's talk now back at our function. So, give me a number close to negative 5, but on the left side of negative 5. Negative 6. Okay? So let's go negative 6. So this is going to be negative 6 over what? Over what? 36 minus 25, right? Which is 11. So what's that one going to go to? Negative infinity, because it's negative. Shooting down. Why it's been hopping like that today. Now, pick me a number close to negative 5, but on the right side. Negative 4? Okay. So that's going to be negative 4 over what? Negative 4 over what? Over negative 9. Negative 4 squared is positive 16. Minus 25 is negative 9. Negative 4 divided by negative 9. So it's going to go where? Now let's go to the left side of positive 5. What's on the left side of positive 5? 4. That's going to go to negative infinity. What's on the right side of 5? So that's going to be positive 6 over 11, wasn't it? That's going to go to positive infinity. Okay? So, for any rational function, okay? So f of x equals, rational functions, remember, have a function for the numerator and a different function for the denominator. Okay? So, really the only thing that you're concerned about in a rational function is the lead coefficient and the degree. Everything else is just extra. Okay? So, the very first thing that you have to do is you have to, from yesterday, step 1 was find any and all vertical asymptotes. Right? We find the domain at the same time. So we find those by where the denominator is equal to 0. And then our vertical asymptotes, we write them out separately, are x equals each individual restriction. Right? Learned that yesterday. Today, we're going to go on to step number 2. Step number 2 says find the horizontal asymptote. Now, with the vertical asymptote, how many can there be? Many as you have restrictions for, right? Okay. The difference is that the horizontal asymptote, there can only be a maximum of 1. You're either going to have 1 or you're not going to have any at all. Okay. We find the horizontal asymptotes by comparing the degrees of the numerator. Math term, degree. What does it mean? We've used it before. Some of us have even used it today. What about the exponents? The degree is something even more. The biggest exponent. Now, so I'm going to compare a number from the numerator to a number in the denominator. So I'm comparing two numbers, right? When I compare two numbers, what are my options? If I'm comparing two numbers, what are the options? Nope. Compare 5 and 8. So one option is what? One's bigger than the other. Or one's smaller than the other. Or they're equal, right? So either the top degree is going to be bigger than this bottom degree, or the top degree is going to be smaller than the bottom degree, or they're going to be equal. When you're comparing two numbers, that's the only three options you can have. One's bigger, one's smaller, or they're equal. Okay? So, option number 1 says that the top degree is bigger than the bottom degree. And if that's the case, where the numerator degree is bigger than the denominator degree, there is no horizontal asymptote. So for instance, 7x cubed over x minus 4. That function would not have a horizontal asymptote. I don't even want to tell you what it is, because you're not going to be happy with it. That asymptote is a parabola. It's a parabolic asymptote. Maybe. Okay. Option number 2. If the bottom is bigger. So now the top is smaller than the bottom. If that's the case, y equals 0 is your horizontal axis. Gotta make the bottom bigger. Equal. equals 0. Because it's a line. 0 is just a number. Okay. Third case is if they are equal. So if the top equals the bottom. For instance, something like 2x over 3x plus 4. Or, actually here, let's just go x plus 4 there. Because then that gets me what I wanted to, the way I wanted to show it. Or x over 2x minus 8. If that's the case, where they're equal, your horizontal asymptote is the line y equals a divided by b. A is the lead coefficient of the top, okay, and B is the lead coefficient of the bottom. So, looking at these two, what would the horizontal asymptote be on this first one? Choose a number. Y equals 2 is a horizontal line. On the bottom one, what's the horizontal asymptote? Y equals 1/2. Put it to work. Find the domain of the function and identify any and all horizontal and vertical asymptotes. Oops, forgot to enlarge it. That's what I was going to do. First one, domain. Agree with x cannot equal -1. X plus 1 equals 0. Subtract 1 from both sides. X cannot equal -1. Which means then, what is my vertical asymptote? X equals -1. Agree with that. Restriction. Horizontal asymptote. Degree of the top. Degree of my numerator. Degree of the numerator is 2. Degree of the denominator is 1. So top is bigger. So there isn't 1, right? So we write that then as no. Don't put 0 there. If it's a 1-point problem and you put 0 there, I'll take 4 points off. 0 is not the same as none, or there isn't one, or NA, or DNE. Is yesterday from our reading skills, does it say how many?
Well, I'm just
Or does it say find them?
I'm saying hypothetically.
What do you think I'm going to say? I know.
I'll just figure it out.
Domain of the second one. Except what?
Yeah, Mariah. Go. Plus or minus. Good job.
Because why, Mariah?
Because you have to put it.
So we got to put plus or minus. Vertical asymptotes. Degree of the top. 2. Degree of the bottom. 2. Those are the same, correct? So that means that I take the coefficients. Lead coefficient on top. 6. Lead coefficient on the bottom. 1. So that gives me a horizontal asymptote of y equals 6. Lexi, you were asking for a shortcut before. Okay? For your end behavior, the horizontal asymptote is what the function goes to at the extremes. So back here on this one where we found end behavior, right?
Yeah.
Our end behavior went to 0 from above and 0 from below.
Yeah.
What's the horizontal asymptote of this one? Y equals 0. Yep. So that's where those come from. Okay? You just have to figure out above or below.
Yeah, that's the only problem.
Okay? Right?
That's the part I have problems in.
Go for it. Bless you. Since I set you all into an uproar, why don't I have to figure out what x minus 2 times x minus 2 times x minus 2 is?
Because if x equals 2, then you're just going to have 0
Right. Right. Okay. So you can multiply it all out if you want, but then you're just going to have to factor it back down to x minus 2 times x minus 2 times x minus 2, which is just figuring out what x minus 2 is equal, or when that equals 0. Okay? So my domain here is all real numbers, but x can't equal 2. Which means my vertical asymptote is x equals 2. Now, what's the degree of the numerator? 1. What's the degree of the denominator? 1. Degree of the denominator? It's 3. Because it's the biggest exponent. Top is 1, bottom is 3. That tells me that my horizontal asymptote is y equals 0. Okay. So, oops, I gotta go this way. My end behavior now. As x approaches infinity, f of x is going to, not equals, f of x is going to approach 0. I just need to figure out above or below. As x approaches negative infinity, f of x is going to approach 0. Again, I just need to figure out above or below. Okay? So, positive infinity. Put a really big number in there, like 1,000. Okay? So the top is what? Put 1,000 in. What's the top? 4,000. Positive, right? Okay? Put 1,000 into the bottom. Really big number. Positive or negative? Positive. So that's going to go positive, positive is going to be above. Now, let's go to negative infinity. So let's go negative 1,000. Top. Negative 4,000. Bottom. A really big negative number, right? Because a negative number cubed is still negative. So I've got negative 4,000 over a negative ginormous number. It's going to go positive again. Okay? With me? If you don't want to put in such a big number, put in like 100. Put in that up there. Not saying you can't use it. Okay? Right? So that's my end behavior. Now, my asymptotal behavior. As x approaches 2 from the left, what does my function do? And as x approaches 2 from the right, what does my function do? Okay. So, give me a number left of 2. Go even closer. 1.9. Okay? 1.9. Okay? With me? 1.9 times 4. Positive or negative? Positive. 1.9 minus 2. Negative, right? Negative 0.1. A negative number cubed. Still negative, right? So I got a positive number divided by a negative small number. Negative infinity. Too far away. Legit, too far away. Because you want to be right tight. Because you want it as it gets closer and closer and closer. Great. This time. Okay? But again, what do I? Okay? 2. Now from the right. We got 2.1. 2.1 times 4. Positive. 2.1 minus 2. Positive. Positive cubed. Positive, right? So what's that one going to? Positive infinity. What's up?
Okay, so for a couple examples like that, we only use -4, -5. So how are we supposed to know when to use like decimals into it, like 1.9 and stuff like that, versus
The more complicated your function gets, the closer to the asymptote you should get. I would always go like 0.1 away, but that's just me. Okay? And again, I'm not thinking actual numbers. I didn't actually calculate what 1.9 times 4 was. Okay? I didn't actually calculate that. I only cared about the positive negative of it. Because your end behaviors are going to go to your horizontal asymptotes. your asymptotal behaviors are going to go to positive or negative infinity. Okay? So I'm not caring about actual numbers. I'm more caring about the positivity of those numbers, or of that function there. Okay? All right? So, domain over here. Nope. Negative 1/3. So that means my vertical asymptote is negative 1/3, right? Okay. Horizontal asymptote. Degree of the top. Degree of the top. 1. Degree of the bottom. 1. So they're the same, so what do I look at? Leading coefficients. What's the lead coefficient on top? Negative 2. What's the lead coefficient on the bottom? 3. So this becomes a horizontal asymptote of y equals negative 2/3. Now, that creates a little bit of an issue, right? Because now my end behavior is going to go to negative 2/3. So I can't just look at positive and negative now, because they're both going to be negative. I have to look now at actual numbers on my end behavior to determine if it's from above or from below. Okay? So, my end behavior is going to be as x goes to infinity, f of x goes to negative 2/3, but now I bless you twice. I got to figure out if it's from above or from below. Okay? So let's pick a number. Big number. 100. Fantastic. If I put 100 in there, so that's going to be 5 minus 200 and 300 plus 1. So that's negative 195 over 301. Correct? Okay. In decimal form, what is that? Somebody calculate that for me. Negative 0.64, right? Right? This is negative 0.66. So am I above or below? I'm above. Now let's go to negative 100. That's going to be 5 plus 200 over negative 300 plus 1. So that's going to be 205 over negative 299. Somebody calculate that for me. Negative 0.68. This is negative 0.66. So that's below. Okay. That's the downfall when the degrees are equal. then you actually have to figure it out. Until tomorrow, when we get to the graphs, then you can just look at the graph. Okay? Okay? Now, we got to do asymptotal behavior over here. As x goes to negative 1/3 from the left, what's my function going to? And as x goes to negative 1/3 from the right, what's my function going to? Okay? Is this a more complicated function? No. So we got singletons, right? We have single degrees on both top and bottom. Okay? So we could do 0 and we could do negative 1. Right? Okay? If I go negative 1, I'm on the left side. Right? Negative 1 would give me 5. Whoops. Negative 1 would give me 5 plus 2 all over negative 3 plus 1. That's 7 over negative 2. That's going to go to negative infinity. If I put 0 in there, that's on the right side, I get 5 divided by 1, which is going to go to positive infinity. So this one is negative infinity. This one is positive infinity. Okay? Again, I get it. Right now, the logic is killing you because I'm making you think about numbers. Okay? It will get easier tomorrow. When we graph these functions, it will get easier. We'll be able to do all of that in under 30 seconds. Because you just got to look at your graph.